find the tensions and the acceleration of the blocks. Relative motion का concept है, तो हम लोग इसको करते हैं. देखिए, so consider the Atwood machine of previous problem. The largest mass is stopped for a moment. The larger mass is stopped for a moment. So suppose we have a pulley and we have two masses, and it starts sliding. So as it starts sliding, so it will fall down. So it is stopped for a moment. So stop for a moment, and after 2 seconds. So first we will see how much acceleration will be there. So acceleration, we can take data from the last question. The data was M1 is 300 and M2 is 600 grams. So this is 300 gram and this is 600 gram. So what will be acceleration? First task is to find acceleration. So acceleration will be M2 minus M1 into G divided by M1 plus M2. So we will do 600 minus 300 into 10 divided by 600 plus 300. So this is 10 by 3. 10 by 3 it will be with 300 by 900. So 10 by 3. So this is the acceleration of the blocks. Now acceleration of the blocks are this. If we stop this block after 2 seconds, so what are the things which are going to happen? So after 2 seconds, what will be the velocity required? So the velocity is v equal to u plus at. So u was 0 initially starting from rest, and acceleration is 10 by 3 and time was 2 seconds. So the velocity acquired by two objects is 20 by 3 meter per second after 2 seconds. So this object is moving upward with a speed 20 by 3 and this is moving downward with a speed 20 by 3 meter per second. Now this larger block is stopped. This one is stopped. So its velocity will be suddenly 0. But this object is not stopped. So this will keep on moving in upward direction. So after stopping, what are the things which has happened? After stopping the M2, the M2 velocity becomes 0. M2 velocity is 0. And M1 velocity is still 20 by 3. M1 velocity is 20 by 3 meter per second in upward direction, in up direction. Okay. So now the question is find the time elapsed before a string is tight again. So how the string will become tight or loose? So that we are going to see now. So since this object is moving upward and this has stopped. So since this object is moving upward, the string will become loose because the string was tight initially, but this object has stopped and this one is moving upward. So what is happening now? This object is moving upward and this has stopped. So the string will become loose. To become string tight again, the displacement of both the objects should be the by same amount in a given time. What I am saying is this object will go up and this may go up and then it may return like this because it is now falling under gravity. The string has become loose. Once the string has become loose, the object will go up and it may fall under gravity. And this object is anyway falling under gravity. If you, after holding it, if you release it, it is falling under gravity from 0 initial velocity. So to become tight again, the displacement of this object and displacement of this object must be same. The displacement of this object in upward direction and displacement of this object in the downward direction must be same. So what we are going to do is for M1, the displacement is, this is displacement S1 will be how much? That will be initial velocity is how much? 20 by 3t plus half that is g, so gt square. So ut minus half gt square, that is we are writing for M1. Now for M2, since M2 is falling under gravity, we will write displacement S2 will be Since it is falling from rest, we can write simply half gt square. This one we are taking in downward direction, this one in upward direction. Why? Because the amount by which it comes down, suppose it comes down by 10 centimeter, and if it goes up by 10 centimeter, then if these two are equal, only then a string will become tight. If the displacement of the upper object is more, the string will remain loose. And that is the thing initially happening. The displacement of upper object will be more initially, but after some time they will become equal. So that we are going to see. So equate these two things. So S1 equal to S2. We will write 20 by 3t minus half gt square equal to half gt square. So if we solve, the tt will get cancelled and we will have 20 by 3, and this side it will be gt. Okay, after doing all the things, and it will be t equal to 2 by 3. So after t equal to 2 by 3 seconds, the displacement of this object and the upper object both are same in the forward direction. Upper object is forward direction, the lower object forward direction is